Good afternoon. In today's session, we have to study about how to solve numericals, which will be on the back EMF equations, generated EMF equations, the torque equations for the DC motor. 8 remaining students will join. Until that, we can revise our equations. So we will get how to solve that numerical. So firstly, what we are saying, when we are supposed to study about the DC machine, at that time we have seen there are two types of DC machines, DC generator and the DC motor. There is no need of video. Okay, हाँ. So अभी आ रही है आवाज ऋषिकेश? Are you there? Rishikesh, my voice is audible to you? Okay, so what we are saying here, when we are supposed to study about the DC machines, we are having two types, DC generator and the DC motor. When we are converting mechanical energy into electrical, at that time we are saying that EMF as a generated EMF, and that device we are saying as a DC generator. And when we are doing exactly opposite functions of the DC generator, at that time we are saying that EMF as a back EMF, because if you see the working for the DC motor, at that time you will get that EMF will work in opposite direction with the supply voltage. Just because of this reason, we are calling that EMF as a back EMF. So here we are supposed to see about the torque equations, and here what we are saying here, we can calculate the torque that will be in the form of back EMF, in the form of armature current, and in the form of speed that is measured in the per seconds. So here we are aware about the torque equations that will be equal to EBIA upon 2 pi n. These equations you will be needed to solve the numericals. And what we are saying? We are saying mechanical power is nothing but equal to IA EB. So we can write PM equal to in the form of torque and angular velocity, because from the circuit diagram of the DC motor we are getting these equations for that power. हमें ये यहाँ से इक्वेशन मिल रहा है P equal to IA into EB. But what we know about the mechanical power, it will be the multiplication of angular velocity and the torque. So we can equate these two equations. When we are equating these equations, you will get the equation for torque, and that will be torque equal to EBIA upon 2 pi. But when we are calculating the EMF that is generated or the back EMF, we are getting the equations NP phi into Z upon 60A. These equations you will also needed to solve the numericals. This N is nothing but the speed in the revolutions per minute. And when you are talking for the small n, we can take that small n in the form of n, capital N, like n by 60, because it is, we are taking that speed in the rotation per second. So here we can take that value as np phi की जगह you can write here small n p phi z upon a, that 60 will get cancelled. You can write in the rotation per minute or you can write in the rotation per second. So here we have seen these equations. Now we are supposed to solve how we will get the back EMF, how we will get the armature current. Before that, you can see here when we will get the equations for back EMF, when we are writing the speed in the rotation per minute. At that time, if you are supposed to solve for the rotation per second, you will get the equations like N Z P phi upon A, because 60 will get cancelled here. Again, what we are saying here, we can write these equations in the form of one constant term. We can consider that as a constant term because we know the Z and pole, these things, and A will be constant. When we are supposed to solve the numericals, at that time we can take number of poles, we can take that speed, that cross-sectional area as a constant term, because what we are saying, Z is nothing but it is the total number of armature conductor. So when we are solving the numericals, at that time that motor will not change, construction of motor will not change. So we can consider these things as a constant term, and when we give the power supply, at that time only there will be change in the magnetic flux and there will be change in the current depending on our supply voltage. Already we have seen how to increase the speed by increasing the armature current. So how we can increase the armature current? By giving the supply voltage. So here we can consider remaining thing as a constant. So here these equations you will be needed. Again, what we are saying, torque equation K phi Ia. This will be needed. Again, the one equations here. When we are calculating the value of supply voltage for that DC motor, that will be back EMF plus the voltage because of armature. We can take that as IARA. So you can talk here like V equal to EB plus IARA, or you can say that will be the E. If you are converting that equation in the form of EB, your equation will become EB equal to E minus IARA. So these equations you will be needed to solve the numericals. So now we can solve numerical. So I am sharing you new one screen where we are supposed to see about the numericals. My screen is visible to you. ये दिख रहा है equations?
Yes, ma'am.
Okay. So there is a question. What is the question? A 20 HP 250 volt shunt motor with armature resistance. RA is nothing but armature resistance. RF is nothing but field winding resistance. So what is they have given here? They have given the value of voltage. That is nothing but given voltage, total voltage. They have given here armature resistance, field resistance, and you are supposed to solve here what is the full load. So here they have given the conditions for no load and the full load. How they have given? You can see here. At no load and the rated voltage, speed is given 1200 rpm. It means what? You can take that speed as capital N because they have written here rotation per minute. Armature current when there is no load, at that time we will get the armature current that will be 3 ampere, and at full load and the rated voltage, the line current they have given, this will be nothing but the armature current. But what they have given, when we are giving the full load, at that time we will get the current as the 55 ampere. So what we are supposed to do here, we are supposed to find the speed, where we are supposed to find the speed with the full load. So we are aware about the efficiency. Efficiency means what? If you will see here, we are getting the equations for the EMF that will be in the form of speed and in the form of current. So here, if you are writing the ratio of EMF for no load with EMF for full load, that will become equal to current field no load. This is the field current and this is the speed no load. F is nothing but for the full load and L is nothing but for no load. And when I am writing again 1F, so this will be for the field current. So here, firstly we will solve stepwise. So what we can see here, we are having the value for RA, RF. So we can take at no load, we will get the value of current because they have not given the value of current. They have given the value of voltage, they have given the value of armature resistance, and they have given the value of field resistance. So you can calculate the current flowing through the field winding. How we can calculate? We can denote that current as I field no load. It means what? No load field winding current. That will be equal to, because we are taking here total voltage, because when we are supposed to solve that numerical, they have given here this motor is a shunt motor. It means what? That armature and that field winding will be in parallel. with the given voltage. So voltage क्या रहेगा वहां पे same रहेगा because parallel में voltage same होता है. So you can take that current as voltage upon resistance. That voltage you can take 250. RF they have given 170. When you are supposed to solve for full load, at that time also I am explaining both things at a time. So you can see here, when we are supposed to solve the value of current for the full load, at that time also, we are supposed to take that voltage, we are supposed to take resistance, that will be same. So you will get the same current for the no load and for the full load. Now, what they have given? They have given here speed, but that speed they have given when there is no load, and you are supposed to find the nfl. It means what? Capital N is means what? You are supposed to find the speed that will be in the rotation per minute, and you are supposed to find that speed for the full load. So that will be nfl. So here, for that you will be needed the ia and ra, because here we are having the equations for the back emf. Back emf, because this is the motor, हम यहाँ पे मोटार ले रहे हैं, so we can call that emf as the back emf. We are having the equations E minus IARE. E means what? जो हम वोल्टेज दे रहे हैं, सप्लाई वोल्टेज, जो अभी मैंने just before we have seen the PPTs for our DC machine. In that we have seen we will get the equation for voltage by using the KVL for the DC shunt motor. How will you get? V equal to EB plus IARE. If you are converting that equation for EB, you will get V minus IARE. But here we are saying that EMF will be with no load, because here we are having the armature current. This is the 3 ampere, and they have given armature current 55 when there is a full load. So your equation will become 250 minus 3 into RA का value है 0.22. These things will remain constant. In full load only the value of IA will change, because they have given here that value of current is 55. So here, if 250 minus 55 into 0.22, you will get that voltage. When you will solve this mathematical term, you will get 238.22 volt. So here, what we are having here, if you are comparing the EMF, back EMF for no load and full load, what we have seen? We have seen these things will be depend on the current and speed. So you can write that equations in the form of current and speed, but we have seen we will get the current same. यहाँ पे भी 1.47 मिल रहा है, यहाँ पे भी 1.47. So you can cut these things and you can write that EMF for no load, EMF for full load, जो हमें यहाँ पे derive किए हैं. Speed for no load they have given. Now, if you are having three terms here, you are supposed to solve one term, NFL, that is the speed with full load, that will be equal to 1200 into 238.22 upon 249.34. If you solve, you will get that value as 1146.5. We can give here unit as a rotation per minute. I will share this PDF to you. You can solve, you can cross check your answer with these answers. Okay, again we can see one another question. If there is one problem, like what they have given here, a 230 volt shunt motor delivers 30 HP. It is nothing but the power they have at the shaft 1120 rpm. This is will be the speed, rotation per minute, capital N. If motor efficiency, efficiency means what? Output power with respect to input power, इनका ratio, what they have given 87%. So you can take here nita is nothing but you can call this n, ये जो n है लंबा, I am taking second line some larger, we can say this symbol as a neta, efficiency. So we can calculate that efficiency as output power upon the input power. What they have given? 87%. They have given output power also. because they have given a shunt motor will deliver 230 HP. Now 30 HP. Now you are supposed to solve value for line current, that is nothing but the armature current, and the total input power. So we are having the equations neta equal to output power upon input power. You can convert that equation in the form of input power. Now you can write that equation as P output upon neta equal to neta. They have given 87%. If you are writing here, you can take that value. There is no need of percent. So 87 by 100, that you can write as a 0.87. So here, when you solve, you will get that value as if you solve that 30 HP, you can take that power HP ki jagah you can take here value as 746. They will give you here. They will give you here. You can take 1 HP equal to 746. So you can take 30 into 746 upon 0.87. So you will get that value of input power will be equal to 25.72 kilowatt. K, W is nothing but the unit for power. Now, what you are supposed to solve again? Line current. So here, we are having the value for power, we are having the value for voltage, we are supposed to find the value for current. We can write power equal to voltage into current. So you can convert that equation in the form of current. You will get power upon voltage. So you can write that power 25.72 kilo ki jagah you can write into 10 raised to 3 upon input voltage. They have given total voltage is nothing but 230 volt. So you can take that as a 230 volt. So you will get upon 230. If you solve, you will get 111.84 ampere. So here again we are having lots of problems. We can see one by one. This is on the top. Okay. So what they have given here, you can see here, a separately excited motor runs at 1045 RPM. That is nothing but speed. You can take capital N because they have given RPM. With constant field current, that current will be IF. While taking armature current, armature is IA, 50 ampere. At 120 volt, they have given input voltage as 120 volt. The armature resistance is 0.1 ohm, RA. If the load on motor changes such that it now takes 95 ampere at 120 volt, determine the motor speed at this load. It means what? Here you are supposed to find the value of speed that will be with this load. So here we are aware about the EMF equations that will be in the form of constant term and phi omega, because what they have given that voltage will not change. They are saying here also 120 ohm. So here we can take that as the constant term E equal to K phi N. K is nothing but constant term, or you can write E equal to N P phi upon 60 into Z by A. But I am taking Z, A, P, Z as a constant term K. That's why I am writing directly E equal to K phi N. Now you are supposed to find with that flux and you are supposed to find with another. But what they have given here, you are supposed to find the speed only where speed is changing. At that time, you can take that magnetic flux also same. So here you can say E1 upon E2 equal to, when you are taking E equal to K phi N. K is constant term, so that will get cancelled. Your equation will become phi N upon N1 upon phi 2 and 2. But if you are taking, if you are considering core is unsaturated and field current is constant, it means what? If field winding is constant, field winding constant है तो field current constant रहेगा. So you can take again phi 1 equal to phi 2 like this जो हमने फर्स्ट इक्वेशन में सॉल्व किया था. EMF will directly proportional with the speed. So you can take E1 upon E2 equal to N1 upon N2. when you will write the value for N1 at that time. You will be needed the value of E1 and E2, but you can solve because they have given the total voltage, that is nothing but 120. They have given the armature resistance. They have given here, you can see here. They have given armature resistance 0.1 ohm. They have given armature current also. When 120 volt and you are taking speed 1045 at that time, current is 50 ampere, and next time current is 95 ampere. So you can take that value as 120 minus 50 into 0.1. Again 50 की जगह यहाँ पे 95. If you solve, you will get E1 equal to 115 volt, E2 equal to 110.5. So what we are saying here, we are saying E1 by E2 equal to N1 by N2. Now we are having the value for N1, we are having the value for E1, E2. You can solve for N2. If you do cross multiplications, you will get the value for N2. That will be 1004.1 rotation per minute. Now, again, if there is a question like a separately excited, what they have given here, that question was on separately excited. पहले जो दो questions थे, these are on the DC shunt motor. Now again, if you see here, we are having the separately excited DC motor which is having the specification like terminal voltage. It means what? Given input voltage 250 volt, field voltage VF. This is also they have given the same value. Armature resistance same. Field resistance 250 ohm. Initially motor was running at 1103. Means you can take that as N. While supplied by rated terminal voltage and the armature current. यहाँ का armature current A1 they have given 120 ampere. While supplying the constant torque, you will require the constant torque, and torque is directly proportional with phi and directly proportional with armature current. We have seen these concepts in our previous session. So we can take T1 equal to T2 because they are saying we are supposed to take constant term. So you can take here phi 1 Ia1 equal to phi 2 Ia2. They have given Ia1 value, armature A1 दिया है उन्होंने. What is the speed of motor if terminal voltage is reduced to 200 volt? So they have given that voltage is 200 volt. But now we are having torque equal to, torque will not change, will remain constant. So you are having the equations T1 equal to T2, and if you are considering that motor is not saturating, it is unsaturating. Like this, here we have considered phi 1 equal to phi 2. Just wait. What we are saying here, if our core we are assumed as unsaturated and field current is constant for the self-excited, at that time you can consider phi 1 equal to phi 2. So torque का equation torque, so Ia1 equal to Ia2 you will get here. Ia1 equal to Ia2 because you are considering your core is not saturating, you are considering that fluxes will remain constant. So you can take Ia1 equal to Ia2 because you are taking phi 1 equal to phi 2. Ia1 का value उन्होंने 120 ampere दिया था, so we can take Ia2 also as a 120 ampere. But we are having the equations for EMF and the speed. So here again you can solve voltage for that current which is we are having as a 120. But here if you see what they have given here voltage will be reduced. They have given first time you are supposed to take terminal voltage 250 volt, but when you are considering constant term, at that time you are supposed to find the speed, but terminal voltage will reduce to 200. So your equation will become V minus IARA. That time VT2 you are supposed to take as 200, and VT1, this is the terminal voltage, you can take that as a 250 volt. बट यहाँ पे करंट का वैल्यू सेम है, करंट का डिफरेंट नहीं है. बाकी जो क्वेश्चंस थे they have given the value of armature current different, but here we are taking that ore is unsaturated, these fluxes will remain same, torque will remain constant. That's why we can take ia1 equal to ia2. So you will get equations for e1 and e2. So if you solve this mathematical term, you will get the answer. So if you are solving for n2, your equation will become n2 यहाँ पे जाएगा e1 upon e2. If you are solving for n2, your equation will become e2 upon n1 because you are going to the other side. So your equation जो यहाँ
Hello,
हाँ
ma'am. Your voice is not coming in the between.
okay, two others, कपिल
Yes, ma'am.
कपिल संकेत सुरेश, सभी को इशू है आवाज में. But just now I have taken the lecture for the electronics. They have not talked anything like means voice is not coming. Now,
Middle only is
No,
for
ma'am, no
some
problem.
time.
okay. नहीं, but remaining
आ
time.
रहा है मैडम.
Okay, maybe there was network issue, Bhujbal.
Okay, ma'am.
Okay, so you can see here when we are having the values for all these terms, you are solving the values for E1 and E2. They have given already the value for N1. So you can put this value. So you will get the value of speed. That will be when you are taking the torque as a constant. So you can determine that speed when we are considering that load. So you will get N2 equal to 1004.1, and you are taking that speed in the rotation per minute. So you can give unit as a RPM. Again, we can see one example, but this is the similar, so we can skip. I will share this PDF. This is the same question. This is also the same. This is quite lengthy. Na? I will explain. Okay. So here, what they have given here, the speed of 500 watt. It is nothing but the terminal voltage, or you can take supply voltage, VSVT, 500 volt, is to be raised from 700 rpm to 1000. You can take N1 as 700, so your N2 will become 1000 by the field weakening. It means field winding, or you are doing the weakening. The total torque remaining unchanged. So again you will get τ1 equal to τ2. That will be phi1 Ia1 equal to phi2 Ia2. Here, the armature and the shunt field resistance. Armature resistance RA, field resistance RF. Respectively, they have given. The supply current at lower speed. They have given that current lower speed, you are taking L. Lower. I lower will be 12 ampere. Calculate the additional shunt field resistance. So you are supposed to find here value for the RF. That will be the field resistance. When we are taking the shunt motor at that time, DC motor के साथ में parallel में we are connecting the field winding. So we are supposed to find the impedance of that field. So here they have given the values of input voltage. They have given value of the field resistance RF. You can see here they have given the value for the RF. So here when you are solve for IF1, you will get according to Ohm's law I equal to V by R. Total voltage we will get 500 because they have given, और यहाँ पे RF का वैल्यू दिया है उन्होंने 750 ओहम. So you can take, you will get that value of field winding current will be 0.67. But when you see here, what they are saying, you are supposed to find that additional shunt field resistance. We are getting the field resistance, but we are supposed to find the additional. So if we are getting here the current, what they are saying, that current will be at lower speed. So you can consider armature current plus field current will be equal to that current. So if you are writing here, you will get Ia1 plus If1 equal to IL1. So you can rearrange, reconvert that equation like this. If1 if you are writing to the right side, यहाँ पे जो प्लस में था यहाँ पे वो निगेटिव में आ जाएगा. So here IL1 they have given 12, so you can take as it is. And when we are taking that field resistance, we will get the value of that field current is nothing but 0.67 ampere. So if you are writing this value, you will get the armature current that will be 11.33 ampere. But again, we are having the armature resistance, we are having the value of armature current, we are having the supply voltage, you will get the value for the EMF. So here at lower speed, if you are solving, you will get E1 equal to 490.93 volt. And you are supposed to solve that, calculate the additional shunt field resistance that will be at higher speed. So here what we are saying, we are again saying we are not changing the torque, so we can take phi1 ia1 equal to phi2 ia2. If you are solving here if you are taking that equation in the form of field current and the armature current, you will get if1 ia1 equal to if2 ia2. Here we are taking that field current will not change, that field current will not change. Here they have given, when we are only taking the speed from 700 to 1000, we are increasing the speed, but here torque is remaining unchanged. Armature and shunt field resistance they have given, supply current they have given. So here we can take that value of field current for lower speed and higher speed same. At that time you can take that if ka square, so your equations will become here. If you are writing the values for phi 2, phi 1, n2 and n1, you can reconvert your phi in the terms of field current. if1 just we have solved, if1 हमने अभी जो solve किया है, we are having the value, so you will get e2 by e1. e2 e1 हमने अभी solve किया है यहाँ पे, we are not having the value for e2, but e1 we are having the value for n1 because they have given here the speed, what they have given, n1 का दिया है n2 का दिया है. So we are having value for n1, we are having value for n2, if1 we are having. So here if we are putting these values, we are not aware about if2, we are not aware about that emf, but we are having the equations for that emf, back emf for the second case, higher speed, v2 minus ia2 r2. So here we are having these equations. If you solve this, you will get E2's value in the form of IF2. So you can write that equations in the equation 3. So here you will get equations which will be in the form of IF2. So you will get the value for the IF2 here. And when you will get the value for IF2, if you put the value of IF2 here in this equations, इन दिस इक्वेशंस, हमें यहाँ पे ऑलरेडी n2 n1 पता था, if1 पता था, e1 पता था. What we are doing here, we are writing e2 equation in the form of if2. So our whole equation will become for the if2. So you will get the value for the field current that will be for higher speed. तुम्हें यहाँ पे if2 का वैल्यू मिल जाएगा. At that time, when you are rearranging that equations and you solve, you will get if2 equal to 0.465 ampere. And if you solve these quadratic equations, you will get two roots, if2 equal to 0.465 or if2 equal to 0.012. But if you see that value is near to the if1, so we can consider that value, and it is very less as compared to the if1, so you can reject that root, you can consider if2 का ये 0.465 value. But we are supposed to find that current, we know now we are supposed to find that resistance. How we'll find? According to Ohm's law, again we can take I equal to V by total resistance that they have given when we are having lower speed and when we are having higher speed. Lower speed का resistance already उन्होंने दिया था, so we can put as it is. Supply voltage they have given, if2 we have calculated. So if you put these things, you will get the value for if that field resistance at the higher speed. So that value will be 325 ohm. You can practice. If you face any issue, you can ask me. Okay. This is also the same. But it is quite lengthy because they have given here you are supposed to find the efficiency. Just because of that. They have given here some losses, copper losses. They have given here. That's why. Yeah. So here. What they have given here 220 volt 7 HP. So you can take 7 into 746. That will be the power will be in the watt. DC series motor coupled to a fan. Motor draws 25 ampere, runs 300 rpm. I have written here which values they have given. Okay, so here what we are supposed to solve? Determine the power supply to the fan and torque. You are supposed to find the torque and you are supposed to find the output power. And you are supposed to neglect here the losses. Which losses? The rotational losses. And again, the speed is reduced to, they have given here speed 300, but in second question when you are supposed to derive at that time, you are considering that speed is reduced to 200 rpm by inserting external resistance. Again, there are two resistors. They have giving here one external resistance. So you are supposed to find that value of external resistance and power delivered to the fan. So firstly, we will try to solve question A. We are having here the circuit, which is nothing but DC series. DC series. So your EMF equation will become equal to IA plus IA into bracket में RA plus RF plus EB. So here when you are solving for back EMF, EB. If you are taking here EA, that is nothing but the armature EMF. If you are taking, your equation will become E minus IA in bracket RA plus RF. Here RF is also coming. Otherwise, we are taking EA equal to VT minus IA RA. But यहाँ पे additional RF क्यों आ रहा है? Because they have given here, this is the DC series. So DC series है, at that time we are supposed to consider these both resistors. So here all values we are having, if you put these values, you will get the value for EA. Now, we are supposed to find the power. We know power is nothing but current into voltage. So you can take that power equal to EA RA. EA का value है हमारे पास, RA we are having, so you will get that value. But here they have given you are supposed to determine the power supplied to the fan. Also, you are supposed to find the torque. So we are supposed to find the torque, and we are aware about the mechanical power that will be equal to PD equal to P out equal to in the form of torque, angular velocity into torque. But we are not having the value for speed. You can reconvert that equation for the torque. मैंने बोला है P equal to torque into speed. तो torque equation क्या हो जाएगा? P upon angular speed. हमें angular speed का value नहीं पता है. But we are having the value. That is they have given in the rotation per minute. N1. So you can write that value in the rotation per second because you are supposed to solve your value for the torque. So you can take 2 pi n upon 60. 2 pi into 60, 2 pi into 300 upon 60. If you solve this, you will get value of torque. Again, when we have seen the characteristics for torque speed, torque with armature current, at that time, what we have seen, torque is directly proportional to the armature current. It is directly proportional to the square of speed. So you can take tau 1 upon tau 2 directly proportional equal to n1 upon n2 whole square. So directly proportional, so you can give here equality sign. So here, when you are solving, you can write in the form of torque T2 because you are supposed to find the value for T2. And 2 they have given, we are decreasing from 300 to 200. So you can take here 200. And 1 they have given 300. And we can take T1 as a 155.25. Firstly, I will take attendance, then we will continue again. Just wait for me. Huh. Okay, what we are saying here? Huh. So here, you can see here, we are taking the value for n2 n1, we are having the value of torque जो हमने अभी derive किया था यहाँ पे 155.25. So here when we are putting all this value, you will get the value for tau 2. But what we are saying here, we are saying here for series DC motor that field winding and armature current will be in series. So that current will remain same. We can take here IF2 equal to IF1 equal to IA2 upon IA1 because they are saying here we are supposed to solve for series motor. So you can write your EMF equation in the form of armature current. E2 upon E1 equal to IA2 N2 upon IA1 N1. But when we are supposed to for decision at that time, you can't take IF equal to IA because वहाँ पे voltage same होता है, current different होता है parallel में, but series में current same होता है. That's why we are considering field current equal to armature current. So here, when we will put all these values, we are not aware about IA2, we are not aware about E2. So you will get the equations for E2 in the form of IA2. But here, when we are solving the equations for torque, we are having the equations torque equal to EIA, or you are having the equation P equal to TW, torque into angular velocity. If you are equating these equations, already we have seen these equations in the torque equations. So we can take torque omega equal to EIA. So I am rearranging that equations to derive the value for torque T2. So if you will write that value of omega in the form of speed, that is nothing but the reduced speed, new speed, 200. But you are calculating here in the rotation per second, so you can take 2 pi 200 upon 60. If you solve, you will get the value for torque, which will be you are having the value for torque, so you will get the value for the armature current. So here we are having the value for armature current. So now you will get the value for E2. How? Because we are having the value for back EMF will be equal to V2 minus IA2 plus RA plus RF. They have given here we are taking one extra resistance. So we are supposed to take that resistance also. So here when you solve, we are having the value for E2 in the form of IA2. IA2 का value पता है. When you are putting IA2 value here, you will get the value for E2. So here that value will be 5.2 into IA2 का value कितना है 16.67. So you can write 5.2 into 16.67 equal to these values. We are not aware about REXT. If you are writing all known terms and only one unknown term, you will get the value of that resistance. And as you will get the value of that resistance, you will calculate here that resistance as well as that output power. That will be equal to IA2, EA2. IA2 already we have derived, EA2 we have derived. So you will get that power equal to 1445 watt. Okay. Now I am taking your attendance. Okay. We can conclude our today's session. You guys can leave now. If anyone is facing any issue, you can ask me. Otherwise, you can leave now. Okay. Thank you.